Welcome back. Let's dive right into part 2 of this explainer, tracing the incredible 12-year sprint that took the Azipod from a single radical prototype to an absolute industry standard. If you're at all fascinated by how heavy marine engineering can scale up literally overnight when a good idea hits the water, well, you're in exactly the right place.
First up, a quick recap of the Azipod origin. To set the stage, you'll remember from part 1 how it all kicked off. An engineer noticed the unusually broad stern of the OTSO icebreaker, which directly led to the 1989 Siley prototype hitting the water at 1.5 megawatts. That was the spark. They proved you could put a motor directly into a pod under the hull, instead of using a traditional shaft and rudder. But what happened next?
That brings us to the massive power leap. Let's look at our first major milestone in 1994, because the speed of this scale-up is frankly staggering. In 94, we get the first true icebreaker application on the Rodelstein using 2 pods at 560 kilowatts each. But then look at the very next year. In 1995, the Azipod breaks right into the passenger cruise vessel market with the Elation, which was outfitted with 2 massive 14-megawatt pods. Think about that for a second, going from a 560-kilowatt icebreaker to a 14-megawatt cruise ship in just one single year. It's wild. 14 megawatts. Hitting that number per pod in 1995 was the real breakthrough here. You might be wondering, why did the passenger market jump on this so fast? Well, it proved the Azipod wasn't just some niche tool for breaking ice. It gave them extreme reliability, freed up a massive amount of space inside the hull, and offered totally unparalleled maneuverability. Plus, and this is huge for luxury cruises, it massively reduced vibrations. It completely changed how shipyards designed their passenger vessels from the ground up.
Next, we move into refining the Azipod design.
With the power now successfully scaled up for megaships, the late 90s were all about tweaking the physical hardware. In 1998, the Europa vessel really pushed the envelope. They introduced the very first mounting block, which was an absolute game-changer for shipyards because it standardized installation and minimized yard time. The Europa also brought us the first Azipod equipped with a steering fin, a super smart addition to boost hydrodynamic efficiency and keep the ship stable when cruising at high speeds. By 1999, things got even bigger. The Voyager of the Seas installed 3 14-megawatt units. But the coolest part here is the introduction of the industry's first fixie pod. A fixie pod is exactly what it sounds like, a dedicated, non-rotating unit. They installed it right alongside the fully 360-degree rotating pods, so the rotating ones handle all the intricate steering, while the fixie pod just sits there providing massive, efficient forward thrust. It was a brilliant hybrid solution for incredibly heavy ships.
Which leads us right into the compact tackless era. As we crossed into the year 2000, the megawatt systems were totally proven, so the focus shifted to standardizing for smaller ships. Enter the compact Azipod. The traditional pods were amazing, but they were basically custom-built mega-engineering projects for high-powered vessels. Launching the compact Azipod as a standard commercial product meant smaller, open-water ships, supply vessels, and ferries could finally get in on podded propulsion without breaking the bank.
Now, as this tech spread to offshore vessels, the engineering actually got even smarter. Let's do a quick knowledge check. Which milestone represents the first time Azipod RPM was controlled without any physical speed sensor on the shaft? Think about how huge that is. Removing a physical sensor in a harsh, heavily vibrating marine environment instantly eliminates a massive point of physical failure. Did you guess it? The answer is the 2001 installation on the offshore supply vessel UT-745, the Norman Rover. This was not only the first compact Azipod installation, but a genuine industry first, a completely tackless setup. It proved you could perfectly control propeller RPM using just the drive's internal electronic estimations. No need for a delicate physical tachometer strapped to the shaft. It was a massive leap in digital control that made the whole system incredibly robust. And there we have it, the complete picture. You came into this explainer only knowing an icebreaker inspired a new motor, but now you can trace the entire 12-year sprint, from the 1987 patent and 89 prototype, to the first icebreaker in 94, the cruise breakthrough in 95, the fixie pod in 99, and finally reaching that standardized tackless product in 2001. Now that you know exactly how the Azipod evolved from a wild idea into a global standard, it's time to learn the language you're actually going to use to operate one. But it does make you wonder, with innovation moving this relentlessly fast, what will marine propulsion look like 12 years from now? Let's move on to our next core topic, core operational terminology, and I'll see you there.